All right, class. Welcome. Today we're going to be going over Objective 6, which we will be solving linear equations of the forms ax plus b equals c and ax plus b equals cx plus d. Okay, so for part 1, we're going to look at ax plus b equals c. So for these particular problems, let's get some examples going. Okay, so for example 1, we have to solve 3x minus 7 equals negative 5, okay? So with these particular problems, remember we are solving for x, so we want to get this x by itself. In our end result, we want to have x equals something, okay? So we have to think, okay, if we want to get this x by itself, we need to do everything to get all of this other stuff over to the other side. So the 3 and this minus 7 is stopping us from having the x by itself. But we cannot mess with the 3 yet because we have to get rid of the negative 7 first. So when moving things over to the other side, you want to kind of go in like the opposite direction of the order of operations. So we're going to move this first, then we will be able to move this. So let's look at the negative 7. The negative 7 or minus 7 is because it's subtraction. Because it is minus 7 or negative 7, a way to cancel it out is to make it 0 by plus 7 or adding 7. And because this is an equation, whatever we do to one side of the equal sign, we have to do to the other side of the equal sign. So we have to add 7 to both sides. So of course, negative 7 plus 7 is 0. That's exactly why we did all of this. This is exactly what we want. So now on the left side, we are left with 3x. And on the right side, we have negative 5 plus 7, which is 2. Okay? At this point, we still want to get the x by itself. This 3 is in a way. This 3 is being multiplied by the x. So in order to get rid of it or cancel it out, whatever y'all want to call it, we need to divide by 3 on both sides, okay? So because the 3 is being multiplied, to get rid of it, we divide. So 3 over 3, we know is 1. So we're left with 1x, which we just can say is x. And then we're left with, on the right side, 2 over 3, okay? We can just leave it just like that as a fraction, and boom, x equals 2/3. So for example 2, we have 5x plus 7 equals 10. And we are told to solve. So we want the x by itself. So we first need to tackle this plus 7 and make it a minus 7 on both sides. Plus 7 and minus 7 is 0. So we're going to rewrite our equation with what we have left. We have 5x equals 10 minus 7, which is 3, okay? Same situation we were just in. We have 5x equals 3. The 5 is being multiplied by the x, so in order to get rid of it, we have to divide by 5 on both sides. 5 divided by 5 is, of course, 1. So we are left with x on the left side, and on the right side, we have 3 over 5. And because that is a fraction in its simplest form, we can just keep it like that, okay? For example 3, we have things a little different. So let's take a look. We have 5 equals 9 minus 2x, okay? So Some of you may want to move this 2 over here, this 2x over here. You can do that, but where you guys go wrong is you do not do the opposite. You just move stuff. Just put stuff wherever you want to put it at. And that's not how this works, okay? You have to do the opposite of the operation. So let's take a look at that. Let's just look at that. Let's do it both ways. So this way we're going to move this over here, okay? So if we want to do that, because this is minus 2x, we have to add 2x. Okay? So minus 2x plus 2x is 0. And now on this left side of the equation, we don't have a term over here with the x to combine it with, so we just have 2x. And we have this 5 over here. We don't have a negative in front of it, so we know it's positive, so it's plus 5. Keep our equal sign, and then on the right side, we have this 9, okay? So now we can subtract 5 on both sides, and we have 2x equals 4. And when we divide both sides by 2, we get x equals 2, okay? So you can move this to the left side if you want to, so that you can have it set up like x equals blah, 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 okay? But you don't have to do that. So let's explore the option of if we don't do that. So this is our original problem, and we're going to leave this over here. So we want to get the x by itself. So that means we can't mess with this 2 yet. So let's look at the 9. The 9 is positive, and we know it's positive because it does not have a negative sign in front of it. So because this is positive, the way to get rid of it is to subtract it. And what we do on one side, we have to do on the other side. So 5 minus 9 is negative 4. And on this side of the equation, we have negative 2x left, okay? We still want to get x by itself. So this negative 2 is being multiplied by the x. So we have to divide both sides by negative 2, okay? And y'all remember, when we take a negative number and divide it by another negative number, we get a positive number. So negative 4 divided by negative 2 is positive 2. And over here, negative 2 over negative 2 is just 1. So we have x. And you can rewrite it as x equals 2. And boom. So you can get there both ways. I personally don't waste time trying to move it over to the right side just so I can work it, because I know that it will work out, you know, if I leave it over there or not. So because this is an equation and we have that equal sign, it's going to work out as long as what we do to one side, we do to the other side, okay? So let's look at number 4. We have 2 equals 11 plus 3x. All right, so we know we want to get this x by itself. So we can't mess with the 3 yet, but we can move this 11. So this 11 is positive, so to move it, we need to subtract 11, okay? 11 minus 11 equals 0, and that's exactly what we want. So now 2 minus 11, that gives us negative 9. And on the right side, we have 3x, okay? At this point, we know what to do. We divide both sides by 3 because the 3 is being multiplied by the x. 3 over 3 is 1. Negative 9 divided by 3 is negative 3. So we know that x equals negative 3. All right. So that was example 1, 2, 3, and 4. Now let's look at 2 more examples before we go to part 2. Okay, so in these next 2 examples, we have another feature added, if you want to call it that. So what a mistake that I see all the time, people say, okay, 2x and then negative 5x. So let me add 5x to both sides. Okay. Now this is absolutely incorrect because for one, these on the same side. And 2, this equal sign is right here, which the whole same side phrase is talking about the side of the equal sign. So once again, they still on the same side, so we cannot do that. So first, before you can start moving stuff across the equal sign, you want to make sure that each side is simplified. So all of the problems that we have done before this point, please note that on the left and the right side, it was fully simplified. It wasn't anything that you could add as far as, combining like terms. So in these particular problems, we do have terms that we can combine. So you need to combine your like terms before you start moving stuff across that equal sign. So let's look. This is the left side of our equation, and this the right side. Same over here. We're gonna work these at the same time. So for number 5 and 6, on the left side of both of these equations, we have 2 terms with an x in it, which means that these are like terms and they can be combined. So over here, we got 2x minus 5x. So that will be 3x. This plus 4 is nothing over here that we can combine it with at the moment, so we just gonna keep it the same. Then we're gonna keep our equal sign and our 10. From this point, we still want to get this x by itself. There's no other x's that we can combine this with. So now we need to look at the numbers. These numbers need to be combined. So the way that we do that, in order to get this 4 over here to the right side, we have to subtract 4 on both sides. So 4 minus 4 is 0. So we're left with negative 3x equals 10 minus 4, which is 6. Okay. From here, we have negative 3 being multiplied by x. So we divide both sides by negative 3 to get x equals negative 2. All right. Now let's go back over here to number example 6. We got an x and we got plus 4x. So that means in all we have 5x. Okay. So 5x, then we have this minus 5 that we're just going to bring on down. We're going to bring down the equal sign and we're going to bring down that 25. So now, still want to get the x by itself. Can't mess with the 5 just yet, but we can mess with this negative 5 or this minus 5. So we're going to add 5. So, and look, I'm writing this under the things that is alike, okay? So negative 5 plus 5 is 0, and 25 plus 5 is 30, and on this side we're left with 5x. All right. So we got 5x equals 30. The 5 is being multiplied by the x. So the way to get x by itself is we have to divide both sides by 5. So when we do that, 30 divided by 5, we're going to get 6. All right? If you need to write this step in, by all means, please do. All right, so now let's take a look at part 2. So with part 2, we are looking at that form ax plus b equals cx plus d. Okay, so looking at this first example, we see that on the left side, we have a term with the x in it, and we have a number, or we call it a coefficient. No, we call it a constant because it does not have a variable with it. The coefficient is the number in front of the variable, okay? So on the right side, we have a term with an x, and we have a constant term without an x, okay? So both sides is simplified enough. There's nothing that we can combine on the individual sides. So at that point, now we can start moving things across the equal sign. So make sure that that is the case before you start moving things, okay? So now with number 1, we have 2x plus 3 equals 5x minus 9. So our ultimate goal is we want to get the x's to one side and the numbers to one side so that we can see what x equals. So let's look at our x's first. We got 2x over here and we got 5x over here. So let's go ahead and subtract 5x. And we are subtracting 5x because it's positive. So 5x minus 5x is 0. So when we do that, we get 2x minus 5x, which is negative 3x. We still have that plus 3. We still have the equal sign, and we still have that negative 9. Okay? Now, we need to get the constant terms together. So this plus 3, we need to subtract 3. 3 minus 3 is 0. Then we are left with negative 3x equals negative 12. From here, y'all got this. We divide both sides by negative 3. Negative 3 divided by negative 3 is 1. Negative 12 divided by negative 3 is positive 4. And boom, x equals 4. Okay? Easy peasy. So with these, you want to make sure that each side is simplified, meaning you don't have any like terms to combine on the left or the right side. Then at that point, you are able to start moving things across. So let's look. We got 4x minus 5 equals 8x minus 7. So let's go ahead and subtract 8x on both sides. So 8x minus 8x is 0. Perfect. That's what we wanted. We was trying to get rid of it. So we got 4x minus 8x, which is negative 4x. Then we still have that minus 5, still have that equal sign, still have that minus 7. Okay? Now, we need to get this negative 5 over here with the negative 7. The way that we do that, we have to add 5. You guys cannot forget to do the opposite. So negative 5 plus 5, of course, is 0. That's what we wanted. And negative 7 plus 5 is negative 2. On this left side, we still have our negative 4x. So the negative 4 is being multiplied by the x, so we need to divide it to get rid of it. So negative 4 over negative 4 is 1. So on this side, we just have 1 times x, which is just x. And on this side, we got -2 divided by -4. And this is also a fraction that can be simplified. So because a negative divided by a negative is positive, then our ending result is going to be positive. And 2/4, we can simplify that to be 1/2. So the answer to example 2 is x equals 1/2. So let's move on over to example 3. And you can definitely pause, rewind, do whatever you need to do to make sure that you fully grasp these concepts. So here, let's look at example 3. We want to make sure that both sides are simplified, that we don't have any like terms to combine on each side, and we don't. So we can jump right in and move this x over here and move this over here. So I'm going to write it in one step. You do not have to do this. Please write all your steps if you need to. So I'm going to subtract 10x on both sides because it's positive right here. So I'm going to subtract it on both sides. And this +4, I'm going to subtract it on both sides because it's positive. So now that I have that done, over here I have this left, which is 5x minus 10x, which is -5x. And on this side, I have this left, 6 minus 4, which is 2. All right. So now this -5 is being multiplied by the x. So in order to get rid of it, I'm going to divide by -5, and whatever you do to one side, you have to do to the other side. So in this case, x equals -2/5. Now let's look at number 4. So first step, we need to make sure that on the right and the left side of our equation, that everything is simplified. So let's look at the left side and the right side, okay? So on the left side, I noticed that I got an x term right here and an x term right here. So this side is not fully simplified. So 3x minus 5x, that's -2x. Then I'm going to keep that +4, keep my equal sign. Now over here we have 2 minus 4x, which we have a term with an x, and we have a term without an x, that constant. So we could just copy that on down. Now we have what we need to start moving things around. So I'm going to add 4x because this is minus 4x. I'm going to add 4x. So we got -2x plus 4x. So that's going to give us 2x. And I'm just going to bring everything down. This +4 that I need to get rid of, I'm going to do it by subtracting 4. So we have 2x equals -2. 2 minus 4 is -2. And this 2 is being multiplied by this x. So I'm going to divide both sides by 2. So 2 divided by 2 is x. And -2 divided by 2 is -1. So that is how you do part 2 of objective 6. So we looked at the form ax plus b equals c, and we looked at the form ax plus b equals cx plus d. All right.